Hello everyone, today I am going to start a new project. So I'll be talking about secure computation. So in secure computation I am going to cover two topics, which is a broad area. First is FHE and second is MPC. So in this video lecture I am going to just introduce what is this, what is FHE and what is MPC. First is fully homomorphic encryption. Fully homomorphic encryption. And second is multi-party computation. Multi-party computation. Okay, now we will first start with FHE and then multi-party computation. And okay, let us start basic. What is fully homomorphic encryption? See, in cryptography what happens, suppose you are having a plain text, a message M, okay, and you will encrypt it. So I am going to denote it by this. This means encrypted M. This is your ciphertext. This is your plain text. This is your ciphertext. Okay. Now suppose there is a boy who had some messages, say M1, M2. He has two messages, and he want to do some operation on this. Some function f of M1, M2, which is very difficult, or he won't able to do that, or something like that. It would be very computationally hard for him to compute this function. Say for example, M1 raised to M2 plus M1 M2, something like that. You can visualize M1, or some integration. You say M1 to M2 and something is given X. Some big computation is there, which this guy is not able to do. Then what he want to hire someone who can solve this, who can compute this for him. So we are going to call it as cloud. So it is actually cloud computation. So what this guy want to do, he want to give his data to cloud, and then cloud will give him this data. This is the main idea. But the thing is that here your privacy of the data should be maintained. That means he cannot directly give the plain text M1 and M2. He is not going to give M1 and M2 as it is. But what else he will do? He will make the ciphertext. He will encrypt this message and then send it to cloud. So first, this step 1. This is my two messages I am having. What I am going to do, I am going to encrypt it. I'll encrypt this message with my with my secret, and then I'll give it to cloud. Then I'll give this message to cloud, and the circuit which I want to compute, say the function which I want to compute on this, I'll give that function also to him. Okay. Then what cloud will give? Cloud will compute something, and he will give me this function f of M1, M2, which is again encrypted with my encryption only. That means cloud is going to perform computation on encrypted data. Computation on encrypted data. This is the rule of FHE, fully homomorphic encryption. Now we will be coming why it is called fully homomorphic, what is the meaning of homomorphic encryption, and so on later on in the second class. So basically, what is fully homomorphic encryption? Suppose there is a person who had some messages. He want to compute something on that message. That I am calling it as function f of, say, two message M1, M2. But what happens, you don't want to give its plain message, because see, privacy is more important. He cannot directly give the data to the cloud. So what he is going to do, he is going to encrypt it with some secret which he knows only. He is going to encrypt it, and then he is going to send it to the cloud. Then what is the role of cloud? To compute on this encrypted data and output this function f of m1 m2, which is encrypted by the guy. Okay, then what else? He will decrypt it. He will this guy will decrypt with his secret key, and he will get this f of m. Okay, yeah, that is computation on encrypted data. Now let us come back. What is MPC, multi-party computation? Here also the same thing is going to happen. That is, there are some parties. I am going to say here, parties means there are some person, you can assume, or there are some companies which want to compute something, and this is the parties. Okay, and they are having some messages or some data. Say he is having m1 some secret data, m2, and so on. Okay, so there are, say, n parties, and they are having some messages. But the case is that again they want to compute something, say f of m1 m2 and mn. This is what they want. They want to compute a function which takes the input from all the parties, p1, p2, pn, and all the parties, and they want to compute something. Okay, but the thing is that again these are distrusting party. That means, see, one obvious solution would be, suppose I am going to assign this p2 as a leader, and everybody will give its message to p2, and then we can compute this function. Okay, or for example, you can take suppose there are n parties and they want to calculate average of their salaries. So salaries is a data which you should not share to everyone. Suppose, so what one obvious solution is that everybody tells his salary to this guy, and he can calculate average and tell to everyone. Okay, that is one obvious solution. But in this case, what I am doing, I am telling my data, that is private data, to this guy in plain. So that is what I don't want. So in multi-party computation, what happens? We are going to get this with communicating with each other. That means there are, suppose, p1, p2, p3, say p4, four parties are there. I want to calculate this is the salary 1, salary 2, salary 3, salary 4. What I want to do, I want to compute something. What is that something here? Average of the salary. But I don't want to give my S1, S2, the S1, S2, everything should be secret. So one simple solution for this is, what I will do, this is my salary, I'll put some random number, say R, and I'll send it to this guy. Now if I am sending S1 plus R to this guy, can he get to know anything about my S1, my salary? No, because this is R randomly what I am choosing, and that's what I know. This is one time pad, similar to one time pad. Okay, so I am going to use this R only once. So to my salary I am adding this R and sending it to this guy. What this guy will do, he will add his S2 and send it to this guy. That means earlier it was S1 plus R. Now he is adding his salary to this and then sending it to this guy. And the same happens with this. He will add his salary to the value which he has received from S2. He'll add S3, and at last this guy, he will add his and then send it back to P1. What he will send? He will send S1 plus R plus S2 plus S3 plus S4. Now what this guy will do now? He will just subtract this R which he has chosen at start, and they will get this summation of SIs, that is S1 plus S2 plus S3 plus S4 and divide by 4. He can compute divide by 4, then they will get the, this guy will get to know the average and he will broadcast that average to everyone. So if you observe carefully here, there are two things which is important here. First is privacy. That means nobody is sharing their data to anyone, okay, in plain. And second is correctness. Correctness means what? The actual computation which they want to compute, that should be correct. So this is multi-party computation, because in this case the parties interact with each other and try to compute something. That's why it is called multi-party computation, MPC. Whereas in the case of fully homomorphic encryption, they were involving a cloud to compute something. So in both the cases the computation is going to happen. Okay. Now see, I told you FHE with respect to only one person. There is one more concept that is called multi-key FHE, in which there may be more than one person. So suppose there are n parties, say I am going to introduce multi-key FHE. Multi-key FHE. In the multi-key FHE, what happens? Everybody will have a secret key and private key. Say a private key PK1, secret key SK1. He is also having private key C and secret key. Everybody has its private key and secret key. Sorry, public key and secret key. Yes. Okay. Now secret key is their secret, they are not going to share. Public key will be available for all. What happens? There are two ways. Either they can compute a public key, say PK, okay, and then encrypt their messages with this PK. They will this guy will encrypt their message with PK, this guy will encrypt their message M2, he will encrypt it with PK, and so on with PK. Now what? They are going to give this to cloud. What cloud will give them? It will give the function what they wanted to compute, and it will be again encrypted with the PK. Okay, now the next part is to decrypt. It is encrypted by PK, which is common public key. This is common public key to all. Okay, to decrypt this we need the secret key of all. The secret key SK1, SK2, every secret key is required to decrypt. That means only one person cannot decrypt it here in the case of multi-party computation. So if you compare with in the case of multi-key FHE, to compare with multi-key FHE and MPC, what do you observe? In the case of MPC, party interact with each other and then compute the function. Correct? Whereas in the case of FHE, party is going to encrypt their plain text and they are going to give it to the cloud, and the function which they want to compute, they are going to tell to the cloud, and cloud is going to compute. Why it is called multi-key FHE? Because there are, every person is having their pair of keys. And why it is FHE? Because the cloud is getting the input, that is encrypted data, and it is computing the output which is encrypted again. So cloud don't know what is the message, and he even don't know what is the outcome, what is the value of the function. Okay, this is what multi-key FHE is. So our focus will be on these two only. That is, see, again I am just selling what is secure computation. Secure computation means I would like to compute something on my messages. Suppose I am having some message, I would like to compute securely. What do you mean by securely? That means privacy should be there and correctness should be there. Privacy means what? Every message should be encrypted, or the other guy should not able to get anything about the first one's message. This is the privacy. And what is the correctness? The outcome, this should be correct. Whatever the function they wanted to compute, this should be correct. This is what secure computation is. So this is our new project which we will be doing. Basically we will be uploading lectures on this too. So we will start with FHE first. Okay, thank you so much.